Hey everyone, welcome to this vlog. We have a lot of stuff to show you, me and Justin, and let's get started. So one thing that we worked on in the past few weeks is we wanted a system that is kind of modular, that would allow us to have dynamic walls. Just so for some cases like this is the demo scene that we provide on itch.io for people on Discord that want to test the game and try the different mechanics and stuff. But something that's going to be important in the game is to have dynamic like walls, just so when your character is hidden, that you see what's going on. So as you can see, this is an issue here, like we're trying to play, but even if we can rotate the camera, and even if we have this kind of a dithering effect on the character behind the walls, we kind of want a system a little bit like if you play The Sims or whatever, that will just create some sort of a cutout through walls so you can see and the gameplay a little bit better. So I started in 3ds Max, and I modeled very basic pieces. So you can see them there if I kind of explode this, that I have 4 pieces. So you have a corner like this one, and you have a version of the corner that is lowered like that. And so when the camera, so this is going to be the full like corner wall, and when the camera is gonna be in between the character, we're probably gonna lower that one. You have just a normal wall, and these are 1 meters because I want to use a system, a grid-based system in Unity, and so I decided at 1 meter. We'll see if we change that eventually. This is a wall that is lowered, so same concept, and this is another corner piece but a little bit taller. So I don't think we're gonna use that one here. I think these are the 4 pieces. So I think it's a 1x4, 1x4, and then you have just the normal like 1x1 floor tile. And so I'm gonna bring this in Unity and set up a little script that's gonna toggle between like a full tall wall and the lowered version, and see what we end up with. Okay, so we're back in Unity. As you can see, I imported the wall. There's nothing fancy in here. I created a prefab called wall prefab. I got rid of the floor because it's just gonna be the wall. And I hid all of the different versions. As you can see, they're all there with the same pivot point. And I'm just gonna hide all the ones that I don't need for now. So I'm just gonna keep the 1x4 full wall. And then I'm gonna work on a script that's gonna go from a full version of the wall to like a lowered version of the wall, like so. So obviously now I'm doing it like clicking, but I like to have the script that just goes from one point to another, probably based on like direction of the camera. So I'll go ahead and create a script on the camera that's gonna allow me to know in which direction it's pointing. And then I'll work a script on those pieces to know when they should lower and when they should be tall. Okay, so I started by creating a script on the camera. So this is the camera controller script. And you can see that I created this method here called calculate camera direction, which I'm calculating in, I'm calling in the late update right here on the camera. And it's kind of ugly, but that's the only kind of way that I found for it to work. And so I just calculated manually 360 divided by all of these that I wanted. So I know now when the camera is pointing north, when the camera is pointing northeast, if the camera is between 0 and 22 degrees, and or between 337 and 0 or 360, then I know it's north, northeast, east, southeast, etc. And that's on the camera itself. Okay, so we're playing here. You can see that I'm on my camera right now in the inspector. and I'm gonna go into debug there just to see a bit more info. And you can see my private variable there that says camera direction set to north. And when I rotate the camera, now it's northwest, west, pointing southwest, south, southeast, east, northeast, and etc. So now that I have this data, I'm gonna be able to change up the walls based on in which direction we're pointing. So let's do that. Okay, so here we are in the code that I just made for the walls, and for now I called this class just a structure element in case it's going to be applied to more than walls. Created an enum here for having different types of structures eventually. For now we only have, as you saw, some walls and some corners. Maybe some floors later, maybe even ceilings, potentially different behaviors. This is all the data or variables for different meshes. So I also have a direction here, which is the same for the camera. And I'm specifying, I'll show you in Unity, I'm specifying in which direction this wall should be lowered. It's kind of a manual labor right now, but eventually we're gonna do it all dynamically. And then that's pretty much it. In update, we're just checking if the current camera is in the direction that this wall should be lowered or not. And if it's true, then I'm lowering the wall or corner, and if it's not, then I'm showing it full size. So you can see, ignore that, this is just a debug scene. You can see that when this camera is pointing north, the walls there are hidden, and when I go there, they kind of lower. You can see the effect that I applied with tweening as well. It just like kind of springs up and down. It just suits the vibe a little bit. And the beauty, the point of this, remember, the purpose was to never have your character hidden.
In the last few weeks, I've been working on the customer AI in the game. So for our first pass, we set a goal to have the customer enter the cafe, do a full loop of ordering, and then we'd make the order, they'd receive the order, and then they'd leave the cafe. We started our design by drawing up a rough behavior tree on paper for what our customers will do inside the game, what their behaviors will be. So the default behavior would be for the customers to be walking outside, decide whether or not to go inside the cafe, get in line, and then when they're at the front of the line, make their order, then wait for the order, pick up their order when it's done, and then finally leave the cafe. To start off, we needed a way to tell the AI where to go and also to set a boundary around the whole level. So we decided just to use the built-in nav mesh functionality from Unity. Makes it really easy to just set all your floors as static and then bake them out, and then you have a nav mesh of your whole level. From there, we'll have to set our customers as being nav mesh agents, and then it's pretty easy to set up. We can just use the set destination method for our customers to make them go to different points in the level depending on their state. So to implement the behavior of the customer AI, we decided to make a simple state machine. So it basically just we define a starting state and we keep track of its current state. And then in the update loop, we just run this run state machine method, which basically just goes into whatever the current state is, runs this run current state method where we can control what happens in that state and then return a new state potentially. So then if we return a new state, then it would switch to the next state. So for example, here we have the walking by state. So that's the state where basically the customer is just walking by the cafe and deciding whether or not they want to go in. So here we have defined the next state that we can potentially return in the run current state method. And then we have our chance of visit. So this is just a probability of visiting the cafe. that we just set a random range from 0 to 100. If it's above 50, then they will go inside the cafe. If not, then they just keep walking by. So here in the run current state method, if this wants to visit bool is true, it'll go to the next state and return go to door state. If not, it'll just go to the exit position and return this same state, so it doesn't change states. So here we have the NPC Customer Prefab, which obviously has the nav mesh agent and rigid body collider and everything you need. Has the state machine here with the states, and here we have a component for each state. So the idle state, walking by state, the order state, the pickup order state, the leave cafe state, wait for order state, move to lineup state, move to cafe door state. Next, we need to create a system to manage spawning in the customer AI. So we made this customer's controller class, which implements an object pool to basically spawn in the characters every couple seconds. So with the customers spawning in, we set up some points in the level to actually have the customers line up and have a spot to wait for their order. So now we can actually go to the cache, take customers' orders, and have them wait until we actually finish their orders. Then when we're actually done the order, we can sell it. And then the customer comes, picks up their order, and leaves the cafe. Now that the states, movement, and spawning are working, get rid of this gray capsule and import an actual character model. We end up using the exact same character model and rig as the player character, so it's really easy to just set up a simple animation controller to set up walking animations, idle animations, and picking up animations.
As usual, thanks guys for watching. Feel free to follow us on Twitter, Discord. I'll put all the links in the description below. And see you in the next vlog. And also, if you want to try out the demo build, you can go on itch.io or join on Discord to know the links and